Radioactive decay occurs when an unstable nucleus gives off a form of radiation to try and become stable. The first type of radiation we'll be looking at is alpha radiation. It's the heaviest of the three, causing it to not travel much distance. Alpha radiation consists of 2 protons and 2 neutrons, making a helium nucleus, and is the most ionizing, carrying a 2+ charge, causing them to be attracted to a negatively charged plate. Alpha particles cannot penetrate many surfaces because they are too large to pass through. The second type of radiation is beta radiation. It is in between the other types of radiation in terms of speed, distance travelled, and penetrability, where it is stopped by aluminum. Beta radiation has a -1 charge, as it is essentially just an electron. This also makes it the least ionizing type of radiation. The third type of radiation is gamma radiation. Gamma radiation are photons, which basically means that it's light. Because of this, it can travel endlessly at the speed of light, making it the fastest and able to go an infinite distance. It is ionizing but has no charge, and is able to knock off electrons on other atoms. Due to its size and having no weight, it is the most penetrating out of the three, and it can only be stopped by a thick piece of lead. All these sound pretty scary, but don't worry. Gamma radiation is only dangerous when there is a lot of it, and alpha and gamma radiation will only cause damage if you eat it. Just make sure to check your coffee. Ionization is the ability to remove or add electrons onto an atom. The greater the charge, the greater the ionization ability, which causes cells to change and mutate. This is the reason why radiation can cause cancer and other illnesses. Now we need to look at the rate of decay and how to read graphs produced from this. The half-life is how long it takes for half of the nuclei in an atom to decay. Reading the graph is easy. Each time the concentration halves, measure the time, and that will be equal to 1 half-life.